Alright, so let's have a go at a couple of questions that come from exercise 8.7. One that was asked of me was question 4. We've got that x equals 12 on t, and we have to find dx dt when t equals 2. Right, so the first thing is we need to get this element here, this t, we want to get that in terms that use an indice. So we'll change that to x. Remembering our index laws, it'll be x equals 12 times t to the power of minus 1. And now, finding the derivative is not too difficult. We find that dx dt will be equal to, we take the power and it comes down the front. So we'll have minus 1 times 12 times t to the power of, and what we do now is we take 1 off the original indice, so minus 1 will be minus 2. So finally what we'll have is that dx dt is equal to minus 12t to the power of minus 2. Now what question 4 is actually asking for is that we find the value of dx dt when t equals 2. At t is equal to 2, dx dt is equal to minus 12 times 2 to the power of minus 2. And what you need to be able to do is to see that 2 to the power of minus 2 is really the same as this element here. That's really the same as 1 over 2 squared, and that's going to give us 1 over 4. So what we actually have is minus 12 times 1 over 4, which equals minus 3. That will be our answer. Okay, another question that I was asked to have a look at is question 8. Question 8, we've got function f of x is equal to the square root of x over 2. First step is to change this element here so that it no longer is using the radical sign, the square root sign. We want to use it, or we want to express it so that it's got an index form. So we'll have function f of x is equal to a half of x to the power of a half, because the square root of x is actually the same as, in index form, x to the power of a half. All right, now it's actually asking for us to find the tangent of this function at the point where x is 4 and y is 1. Find the gradient of the tangent. Well, the whole point of differentiation is to find the instantaneous rate of change, or to find the gradient of a tangent at a point on a function. So let's find the derivative of this function. First derivative, remember f prime x, that's another way of indicating the first derivative. The first derivative of this function will be, we bring down this power again, as we had before. It's going to come down the front. So it's going to be a half times the half that we had there in the beginning. And then we take 1 off the original power that was there. So a half minus 1 will give us a minus a half. Okay, and that will be 1/4 x to the power of minus a half. And what you might also realize is that we've got a negative indice here. What we're going to do is rewrite all of this without the index notation, but just with radicals. So we're going to have no indices, no negative powers. We're going to use the radical and we'll put the x in there. That's what it would look like. 1/4 of x to the power minus a half looks like 1 over 4 times the square root of x. And now what we're going to do is find the gradient of the tangent at the point 4, 1. At 4, 1, that means x is equal to 4. Well, we can find the gradient of the tangent. Remember that the letter lowercase m is the symbol that we use for the gradient of any line. Okay, so the gradient of the tangent at the point where x is equal to 4 is going to be given to us by 1 over 4 times the square root of 4, which will equal 1 over 4 times 2, which will equal 1 over 8. So the gradient of this function that we originally had, the gradient of that function at the point 4, 1 will be 1, 8. That's what we get. Question 9 is another question I've been asked to have a look at. Find the equation of the tangent to the curve y equals 1 over x cubed at the point. Okay, so we've got this curve y equals 1 over x cubed. Let's change that from being a fraction and having 1 over x cubed. We're going to change that so the x cubed is just purely, or the 1 over x cubed is purely in index form. Using our index laws, we know that 1 over x cubed is going to be the same as x to the power of minus 3. Now let's find the derivative of that, because we're trying to find the equation of the tangent to this curve. One thing that we're going to need, here's a little reminder over the side here, is that to find the equation of a line, and a tangent is a straight line, what we want is, in the point gradient form, we want y minus y1 is equal to m outside of x minus x1. So what we really want is a point, and we also want a gradient. So we are going to need to find the derivative of this, and the derivative, y dash, which you could also think of y dash as being dy dx. You could also think of it as being that. Y dash is going to be equal to, we take that power and we bring it down the front, so it'll be minus 3x, and then we take the 1 off the indices, so it'll be to the power of minus 4. So to find the gradient, what we now do is we substitute in the x value for the particular point that we're interested in. So here's the point that we're very interested in, the point 2 and 1a, which means at x is equal to 2, that means the gradient is going to be equal to minus 3 times 2 to the power of minus 4. That'll equal minus 3 over 2 to the power of 4. And 2 to the power of 4 is 16, so we have a gradient of minus 3 over 16. Now, to finish this off, to find the actual equation of the tangent, I might do this working in a blue colour just to highlight its difference. The equation of the tangent will be y minus, here's the y1 that we're looking for, it's 1/8. So y minus 1/8 is equal to m, and here's the m that we're looking for, it's minus 3 over 16, outside of x minus x1. Here's the x1 we're looking for, that's the 2. That's going to give us the equation of a straight line. And let's multiply through by 16, which will help get rid of this denominator that we've got here. It's a bit of a bothersome thing. It'll also take care of this denominator here, the 8. So I'll multiply everything through by 16, which means I'll have 16y minus 2 is equal to minus 3 outside of x minus 2. And then if I expand all of that and put the equation of this straight line into the standard form of a straight line, it'll end up being 3x plus 16y minus 8 equals 0.